The high schoolers is over right now.
The little guys are over. High schoolers are coming in.
So I had a question to ask.
Yeah.
So when I went to go do my unit quiz 1.
Yeah, it's messed up.
Okay.
We're gonna go over
in Spanish. It was like I just didn't know if you knew about that. So I just
So-
wanted to make sure I wasn't behind on
So
it.
in you were in. Say it again now.
So like the unit
Mhm.
quiz one, when you go to download it, and
Right.
it takes you to like go like write your answers.
It takes you right back to login.
No, mine when I did it, I could do it, but
Mhm.
like I couldn't figure out how to write on it.
Yeah,
And
it
like the
won't.
letters and stuff was in Spanish. So I was confused.
It's got a huge mess right now.
Okay.
It's a major problem they're having, and they still have yet to figure out how to fix it, which is concerning me. So yeah, it's time for Lab Rats level class. You have your binder. Come find a seat. What you eat? You can eat lunch in here. Sure thing. Yes, sir. Ozzy, come. Okay. I'm gonna go over all that. Okay.
Having someone miss with the code and switch save and complete to the next question.
Yeah, it's a mess. Don't worry. We're gonna fix it all. Okay. It's gonna get
I
fixed
need a
because
little
it's a mess.
cup for my
Yeah. Get you a cup.
Skittle.
Should be right.
My snack. For
There should be
my-
cups up there at the front too. What you need?
Do we need our textbooks?
No, just your binder. You should be good with just your binder. We are gonna start our class now for our senior level. So this is our Lab Rats level class. So you want to have your binder and come find a seat. If you have lunch, you can bring your lunch. Ozzy,
Really?
hey, place.
Why?
Good boy. You wait there.
This is literally the best hydrating drink I've ever tasted.
What have you got?
Prime.
Oh, those are good.
Yeah, see?
I like. All right. Do I have everybody over here?
I have my pen.
Think so. Okay, so first things first, gang. Teacherese is in a bad way. I'm going to get on the phone with somebody today, or at least I'm going to attempt to. I have been in contact with them. They don't know what the problem is, and they don't know how to fix it, but I don't understand how that takes 3 weeks. It shouldn't. It's a concerning thing. So what I'm doing, hold on a second, what I'm doing is I went through and took the entire quarter's worth of homework assignments and put them on paper. Now you have at the end of every lesson, the little page with Rico on the back, and on the front, it says homework, and it says, all of them say go to Teacherese. You're gonna take all those out and replace them with the ones I'm about to give you, okay? That should cover your homework for the quarter while I try and figure out what to do. I don't wanna switch systems because I have 5 years worth of records and assignments in Teacherese. Switching systems will be a real pain, but if they can't fix it, we might have to. So be flexible. If you tried to turn something in and it didn't come in and you emailed it, whatever, what I'm gonna do is I'm gonna go through and send an individual email to every single one of you. If there's anything I need, I'll tell you. If I don't need anything, I'll tell you, okay? You'll get your regular weekly email, and then you'll get an individual email. And I don't do that often because there's 22 of you, that's 22 emails, that's a lot, okay? But that's what we'll do. Any questions before I hand out the homework stuff? Yeah, James.
That question.
Yeah.
but, I had a Spanish class that used Teacherese.
Mhm.
And it ended
Yeah.
last week.
Uh-huh.
And it was a problem in the class.
Was it? Huh? It worked for us up until the very end, this quiz thing. But I don't know what the issue is now. Now, the other problem with Teacherese, I'll tell you this, is that it's used by independent teachers, independent schools like private schools, and small school systems like the township type of school system where they have like, 6 schools in the whole system or whatever. But there's a paid and a free version. Independent teachers, one teacher, can only get the free. I've offered to pay. I'm like, please let me pay so I can have all the features. And they're like, no. They haven't let me pay in the past. That means I have no leverage. I can't be like, hey, I'm paying for this and it doesn't work. That puts us in a spot. So I'm trying to fix it. We've been 6 years with no trouble. But here we are. Caitlin.
Where do I put the sheets again?
The packet that I sent, Or what? Mhm. The packet that I sent out. So if it's, you can either upload it back up, and if you can't make that work, you can put it over here. All your homework and stuff, anything you ever hand in goes in the folders on top of the chest over there under the weird picture. Okay, yeah.
What's homework doing?
Homework is due just when it's always due. So it's due when you come to class the following week. If you're not gonna be here, scan it, send it as a PDF. All right, so here's what we're gonna do. I'm gonna hand these out, but we're also gonna do an icebreaker while I do it. We're gonna do a 2 truths and a lie. So when I hand you, actually Drew, yours are on the copier, so I'm gonna do you first. I'm not gonna hand yours to you now, I'll give them to you later. But we're gonna do 2 truths and a lie, and then we're gonna come back around and we're going to all say the person's name, and then we're gonna guess which is the lie. Everybody know how to do 2 truths and a lie? All right, so Drew, you're up. 2 truths and a lie. Yes, 2 truths and a lie. Be quick, because we got a lot of you. No, you gotta go first. You're on the spot. That's how it works.
Science is my favorite subject.
Okay,
I once tried out for baseball
okay,
and I am almost
be thinking of yours.
15.
Okay, so Drew says science is his favorite subject. He wants to try it out for baseball, and he's almost 15 and 15. Okay, all right, Milo, you're next. Milo, we're going alphabetically backwards because that's how I stacked it. No, truths and a lie, Milo.
I've eaten undomesticated mushrooms.
Okay, that's random. Okay,
I believe that.
I have racist chickens and I think that.
okay, you've eaten undomesticated mushrooms. You have racist chicken, and you play basketball.
Somehow I
That's fascinating. Right, Chloe's trying to regain composure because she's Milo's sister, and I guess she knows of whether or not they have racist chicken. Okay. All right, listen up so you can hear Chloe. Go ahead.
Okay. I live in a house with 20 animals.
Whoa.
Some might be racist chickens.
Might be racist chickens.
Okay.
Okay.
20 animals, there's one. You got it.
I dislocated my knee doing an impression of Obi-Wan Kenobi.
Highly specific.
Yeah.
And last one.
My favorite fruit is bananas.
Okay, so Chloe lives in a house with 20 animals. She once dislocated her knee doing an Obi-Wan Kenobi impression, and she favorite fruit is bananas. All right, Jordan. All right.
Oh no.
All right, 2 truths and a lie, Jordan. Think about it. Think about it before it gets to you so it's fast. All right, what do you think? Oh, by the way, some of you have upside down Ricos. I'm at the point right now where I don't care. It's not for anyone. I don't care. That's how they ran off. All right, what do you think? 2 truths and a lie? Thank you.
No.
Come up with some real obvious ones that are real easy for you to think of. Want us to circle back around? You want to circle back around?
Yeah.
Okay, Yusuf, you're next. 2 truths and a lie. Oh, why? Because I said so. 2 truths and a lie. You don't know?
Oh, you just have that.
Yeah.
I hate math.
Okay, you hate math. One. Hates math. Your brother said he ran 15 kilometers. Do you want to use his or no?
Oh, you may as well.
I play soccer
You used to play soccer. Okay.
and
Yusuf hates math, plays soccer, and
I don't like doing too much homework.
and he doesn't like too much homework. Okay, Yusuf hates math, doesn't like too much homework, plays soccer. Asher. All right, Asher's up.
Alright.
2 truths and a lie.
I was not born in Georgia.
Was not born in Georgia.
Not a single one of my names is English.
Okay, none of his names are English. Stinking.
I do not like swimming.
He doesn't like swimming. Okay, Asher was not born in Georgia, none of his names are English, and he does not like swimming. Liam. All right, 2 truths and a lie, Liam.
I have once done gymnastics.
Okay, we have 2 gymnasts in the room who are going side eyeing you. Okay, keep going.
I have broken my arm before,
Okay,
and I have never played ice hockey.
okay. Liam's never played ice hockey. He's broken his arm and he once did gymnastics. Well, I know one of them is definitely. All right, okay. James, you're up.
Oh, really?
Yeah, okay. 2 truths and a lie, James.
Okay.
I'm not allowed to say anything.
I'm a gymnast, I'm a baseball player, I'm a soccer player.
Okay. Soccer and baseball. Okay, hey, 2 truths and a lie.
And it's the most obvious one.
I'm thinking about mine because you say it all. Don't even react.
Okay. Caitlin? Isaac. Please.
My next?
You're up, Caitlin. 2 truths and a lie.
I jumped out of a window.
Oh, okay. She's jumped out of a window. Oh boy. These are hard. Jumped out of a window.
I've been in 3 musicals.
Been in 3 musicals.
And
Thinking
I
of.
have 3 dogs.
And has 3 dogs. Jumped out of a window.
Anything.
3 dogs. And what was the other 3 musicals? Okay. Garrett, Colin. All right. For whatever reason I write your last name, but I know there's 2. All right, Colin, you're up.
And then James are not allowed to say anything. Right?
All right, this is Colin. What? 2 truths and a lie, Colin.
Science is my favorite subject. I have an older sister and I was recently stung by a wasp.
Okay. Actually, this one's better.
I have an older sister.
Oh, there you go.
Okay,
I didn't hear that one.
Xander. Where do we go? Here we go. All right, Xander. Okay, say you're Xander Colin. You're sent by a wasp. You have an older sister.
And science is my favorite
Science is his favorite subject. All right.
So
Xander.
I'm 11 years old.
11.
I've been in a TV show
Been on a TV show.
and I like bananas.
Likes bananas. Okay, Lucas. You're up.
I extremely dislike mushrooms.
Does not like mushrooms at all.
I have eaten swordfish before,
Swordfish.
and I put my hand in real fire.
And he put his hand in real fire. Okay, real fire, hand, eating swordfish, will not eat the mushrooms. Ridley. All right, Ridley. 2 truths and a lie, my friend.
I once broke my toe while walking on carpet in my own home.
Okay, so we're still walking on carpet in our own home. That's unique.
I'm the self-pronounced queen of rubber duck.
Self-pronounced queen of rubber ducks. Okay.
And my favorite food is broccoli casserole.
Broccoli casserole, her favorite food. Okay. Miss Emily. All right.
I play volleyball.
She plays volleyball.
I hate swimming.
She hates swimming.
I love fish.
And Emily loves fish. Piper.
Swimming, I love fish.
Like eating fish or pet fish?
Like eating.
Like eating fish.
Yeah.
All right, Piper, you're up. 2 truths and a lie.
Wait, do we get to reveal the truth or lie?
Yeah, in a minute.
I've been dance for 7 years.
7 years of dance.
I have a friend in Virginia.
A friend in Virginia.
I've traveled out of the country.
And she's been out of the country. All right. Bailey, last but not least, Bailey. Two truths and a lie, friend.
Alex.
This is why I don't tell him.
I'm doing college classes.
She's doing some college classes,
I've been working for almost a year.
working for a year,
And I have a boyfriend.
working for a living, and she has a boyfriend. Okay, so let's see, Jordan, did you come up with your two truths and a lie? No? Is there somebody who knows you well who can help you come up with two truths and a lie? You guys know Jordan well? Huh?
Well.
Okay. Lucas, go over and give him, or do you have some? Get it?
I think I have,
Okay. You guys just give us one truth and one lie, if that's as far as you can get.
I used to play tennis.
You used to play tennis,
I'm into computer science.
computer science. And. Thinking.
What I was, wait. That's an interesting lie.
That's good, yeah.
I just realized I think,
You can always do something simple like your favorite color. That can be truth or a lie real easy.
or your age. Wait.
Or your age. Yet.
I know you don't. Well,
I'm 2 years old.
He's thinking.
well, that's obviously a lie. I don't doubt that. Okay.
You got one? Okay. We can go with those two if one of them's a lie and one of them's true. Is one a lie and one true so far? Or without give it away? Don't tell me that.
Yeah.
Yeah.
I had 3,
Yeah.
but I don't think it works very well.
I'll throw one out there. It doesn't matter. Don't do anything real easy. Pick an easy one.
Like color or something.
Yeah, color, age, something real easy. We can always come back. All right, we're gonna go back to the student in the kitchen. Wave your hand. Wave your hand. What's his name?
Drew.
Drew. What were his 3 things?
I don't remember.
Okay, Drew, what were your 3 things?
I'm 15. I once tried out for baseball and.
You're 15.
You're other.
Yeah, so I'm 15. I once tried out for baseball.
I don't.
What's your favorite subject?
Science is your favorite subject. Okay, who votes for science being the lie? Baseball being the lie?
Yeah, baseball.
15 being the lie? Which one's the lie? He's never tried out for baseball in his life. All right, Colin. All right, Colin, what were your 3?
I gotta say me. I have an older sister. I was recently stung by a wasp in science. Is my favorite subject.
Okay, sister, who votes for that one? How about the wasp? How about science? All right, what is it?
It's a wasp. It was a yellow jacket.
Oh, I'm allergic.
And-
That's so yeah, they do. Bailey, what were your 3? Working, college, and boyfriend, right? You were last, though I remember. Okay, who votes for the working? Ah, how about the college? How about the boyfriend? Oh, we know you. What's the answer? The lie is?
I don't have a boyfriend and a girlfriend.
Ah, there we go. Okay. All right, Emily, you're up.
I don't remember what it was.
What did she say?
Fish.
Swimming, fish, and
Volleyball.
yeah, volleyball. Very good, Piper. Okay, so which is the lie? Swimming? Fish? Ooh, or volleyball?
I wasn't paying attention.
What's the lie? Fish. She doesn't like fish. Alrighty, Piper, your 3 were
Dance for 7 years, friend in Virginia, and been out
out of the country. Okay, who votes dance for 7 years is the lie?
I can tell you.
Okay, friend in Virginia?
What? Oh, I don't count.
Friend in Virginia?
Enough.
Out of the country. All right, the answer?
yes,
Out of the country.
Yes,
And Bailey is correcting her dance,
For 8 years,
Oh.
not 7.
dance career.
8 years this year.
oh, I wasn't counting this yet.
All right, Caitlin, your 3 were,
I jumped out of a window.
right, window. Who remembers what Caitlin were? Jumped out of a window.
3 musicals.
Oh, 3 musicals, you're right.
We have 3 dogs.
And 3 dogs, okay. Window. 3 musicals. Nobody back there is voting? 3 dogs. Which one's the lie?
Wait.
Jumped out the window, been in 3 musicals, have 3 dogs.
Well, one of them,
Wait, did you get 2 lies?
I actually did too.
Okay, which one's true?
I have jumped out of a window.
Okay, how many musicals have you been
It
in?
was in a controlled environment.
Oh, okay. Sure, I believe you.
That's Tony Cheswilly.
Yeah. So how many musicals have you been in?
I've been in 2 musicals.
2?
One was Kinda.
Mhm.
There was music in it.
Okay, and then how many dogs do you have?
2.
2 dogs. All right, Lucas. Lucas, your 3 were, remind me.
Mushrooms are my least favorite.
Mushrooms.
You eat
Yeah.
the swordfish.
Oh, yeah, swordfish.
Yeah, I put my hand in real far.
And real fire. Okay, who votes for the swordfish being the lie? How about the mushrooms? I'm gonna vote for that one. How about the real fire? All right, Lucas, which is it?
Real fire.
No real fire. That was so exciting.
Like something you would do.
Yeah, done.
I put my hand.
I believed it. All right, Xander's up. Okay, wait.
That's a lie unless you count the one time I touched a spud bullet.
Okay, yeah, that's probably not, yeah. All right, so Xander, your 3 were, help me out. What were his 3? I'm trying to remember now. It's been a bit.
I'm 11.
11?
I was in a TV show.
TV
and I
show.
liked banana.
Okay, is 11 the lie? Is the TV show the lie? Huh? How about bananas? Oh my goodness. All right, Xander, what is it?
Bananas.
Bananas is the lie.
I have been both. We have both
All
have.
right, Liam. Okay, Liam said he's never played hockey,
I've never played ice hockey.
never played ice hockey,
I've broken my arm
broken his arm,
and I once did gymnastics.
and he once did gymnastics. Okay, who votes ice hockey for the lie? Oh my, okay, who votes the broken arm? And how about gymnastics? All right, Liam,
The lie was I have never broken my arm.
never broken his arm. What
I want-
position do you play in ice hockey?
Goalie. I've once
Yeah.
had a bone bruise before.
Had a bone bruise, yes.
If breaking your arm is worse, then I would don't want.
Mm-hmm. Yeah, for real. I do need to get you in touch with my nephew though, like, for real.
That's.
We've been talking about it.
Travel.
There you go. Yeah, my nephew's like, he's trying to push for college teams,
I
so.
have never ever
Mhm.
played ice hockey unless you count yesterday, but that was like my very first ever like official ice hockey practice.
Okay.
So I haven't played in an official ice hockey game.
Okay, excellent. All right, Asher, you had all my names are not English. What were the others?
He's not born in Georgia.
Not born in Georgia, and then,
You hate swimming.
hate swimming, was that it? Okay, so who votes for swimming? All right, not born in Georgia. And names are not English. Okay, Asher, which was it?
Swim.
Swimming.
Yeah.
Okay, like swimming. Yusuf, you didn't like math?
Yeah.
What were the others?
But
Oh man, help us out. Okay. Yusuf, I remember said he hated math,
love
He
science.
didn't like homework.
doesn't like too much homework, and what was
Play
it?
soccer.
Soccer. All right, so who votes for soccer for the lie? Who votes for hates math for the lie? Oh, this is great. Yeah. All right, and then who votes for doesn't like too much homework? I'd say that's a lie too. I know how much work you, so you don't like, you do love math, right? Yes. All right, Jordan, did you come up with any yet? Your 3rd one? Or are you still thinking?
So go again. No. Mustard.
Still thinking?
I think I know.
Okay, what were your 2?
I think it.
What were the 2 that he had? You had, trying to remember. Okay, Piper.
Change one of them.
Okay, well, think about it. We'll come back around to you after we do the rest of your table. All right, Ridley, you're up. You said you were the self-proclaimed queen of rubber ducks. What was the other one?
She broke her toe.
Broke her toe on the carpet, yes, and then what was the other one?
My favorite food is rocket.
Oh, rocket casserole. All right, who votes for the duck queen? That's just too weird. It has to be true. Okay, who votes for the carpet toe break? And who votes for the broccoli casserole? All right, what is it?
I don't like broccoli casserole.
Ah, that girl. All right, Chloe, you said you don't like bananas? Was that what it was? Was it bananas?
I do like bananas are my favorite fruit.
Yes,
And then the 20 animals
20 animals.
You broke your phone.
is actually 19.
20 animals, and then, What was
Oh, yeah, and then it dislocated my.
it? Dislocated her knee doing an impression of Obi-Wan Kenobi. So which was the lie?
Obi-Wan Kenobi, that's just how Milo tells the story.
Oh, okay. Sounds amazing, though.
Playing miniature golf.
Oh, it was miniature golf, not Obi-Wan Kenobi. Okay, all right, James, you said you do gymnastics, baseball, and soccer. Okay, one of them's not true. Who votes for baseball? Who votes for soccer? Who votes for gymnastics? All right, everybody knows, James, you don't play soccer, do you?
He used to.
Oh, did he? All right, Milo, you're up. Yes, they would be were, okay, you had racist chickens,
Basis chickens.
All right.
And undomesticated mushrooms.
undomesticated mushrooms,
Play soccer.
and he plays soccer. Okay, who votes for the chickens? All right, the mushrooms. How about the soccer? All right, yeah, you don't play soccer, do you? Now, I gotta know, explain the chickens.
The chickens, so,
I knew it.
You have to explain this, this is too weird.
so, sometimes they say the race of Nazi chickens because we kind of walked in. And they had made like the Kafka, like the. What? But sometimes they'll just find other chickens that like the same breed and start pecking them.
Oh,
Or at least they did when we bought the second batch and introduced them to the first one.
okay, so yeah, all right.
Okay. I knew it.
So Jordan, if you can't come up with three, why don't you tell us your favorite food? Or did you come up with three? Still thinking. Still thinking. What's your, how about this? What's your favorite ice cream flavor? You can answer that really. You have a favorite?
I'm still thinking what's the two kids sit a lot.
Don't worry, we don't have time to worry about it. So just kind of give us one thing. Like, what's your favorite ice cream flavor? What do you like on pizza?
My.
Do you, what's your favorite pizza topping?
Pepperoni and sausage.
Boom, pepperoni and
What
sausage.
to do with the two truths but a lie
Mhm.
was I had an idea of like, I used to have a French breed of a dog.
Yeah.
I do computer science, I did used to do tennis.
Ah, so those were three truths.
So,
That's
yeah,
all right.
the problem is that they were all true.
Yeah, yeah. Sometimes the lie's harder. All right, so let's start our lesson. Now that everybody knows everybody's name, and by tomorrow, you'll forget who half of you are because half of you are new. All right, so if you did our science last year, this was a breeze. If you didn't, it probably still wasn't very hard. So I'm, like I said, everybody's gonna get an email. Everybody will get an email. What you owe, what you don't owe, what do I still need, whatever. We're gonna iron it out. Don't worry about it, okay? If you manage to like complete that packet and you emailed it or you uploaded it, I'm gonna go ahead and grade it. If not, I'm gonna send it to you separately. Okie doke, so we're kind of like wiping that, all the crazy assignment stuff clean, and I'll tell you exactly what we still need. So Earth's interior and surface. So get your phones out if you have them. We're going to be using Mentimeter today, and we're gonna hope this actually works. So what Mentimeter is it's a survey app. This may fail miserably, but I'm going to give it a try. So there will be QR codes that pop up on the screen. All you do is scan the QR code. It's going to take you to a survey and we'll answer some questions that way. It'll be cool. It does not give you as the person who answered it. It'll be like a bar graph. So many people answer here, you know, so it should be kind of cool. So you shouldn't need an app or anything. You just need to scan a QR when it comes up. Question, Chloe. Oh, it's right here on the front. Way to go. Right here. So it's Rico with the capital R, Rico with the capital R, 1, 2, 3, 4. And it's the Lab Rats Wi-Fi. Question, Jordan.
I don't have a phone.
That's fine. Don't worry about it. It's fine. If you don't have it, you don't worry about it. If you don't have a phone or an iPad, no problem. If you have it, cool. It's just kind of a fun way to participate. We're going to hope this works. All right, so this is basically a lightning fast review of our Earth Science course. So it's important to review these topics because the physical Earth and the space that we're in provide the context for all the forces in motion we're going to be studying this year. This class is all forces in motion, but you have to have some context for it. So in order to have that context, it's important to realize where we are, you know, with regards to the whole universe. So Earth structure now, if it looks like this and has a little thingy here, If you think you know the answer, you put up your hand. I call on everybody at least once. If you don't know the answer, guess. If you haven't answered a question, I will pick you out and call on you. And if you don't know, just say, I don't know. It doesn't matter. You will get a coin no matter what. The coin will go in your little tray here and you will collect it at the end of class and use it on the Skittles machine on the way out. All right, so geology is the study of planet Earth, including its composition. Geologists are scientists who study Earth and its processes. What is the idea that the geologic processes that operate today also operated in the past? Caitlin.
Uniformitarianism.
Uniformitarianism, that's a fun one. All right, so that's the idea that if it's happening today, it also happened in the past. We're talking about not just geologic processes, but specifically in this case, but it also can apply to many, many other things. Like if Earth had gravity today, it probably had it in the past, you know? All right, so Earth structure. So it has a cross section of Earth here. So it can be divided into three main layers, crust, mantle, core. So what is the layer that's the rocky outer layer that's mostly silicate? All right, Liam.
Crust.
That's going to be your crust. Very good. What's the next layer down? All right, Asher.
Mantle.
That's going to be your mantle. Very good. So that's the next layer down. And that's beneath the crust. And it's composed of your hot, solid rock. Now, when we get to the mantle, it's broken down into three other layers. Okay, Yusuf, what's the uppermost layer in the mantle?
The mantle?
The uppermost layer of the mantle. Yeah. Do you know? The upper mantle. Anybody else want to give it a shot? Emily.
Lithosphere?
There we go. Lithosphere. Okay, here's a word. Here's a word. We're going to come upon words every so often that it's really cool to break down into Latin or Greek roots because it will help us know what the word means if we see it out of context. So sphere is a what? A ball, right? Yeah. Okay. What is litho? Anybody know? Hang on. Hand up if you know. Bailey.
Rock.
Rock, stone. Okay, so that's a lithosphere. You may hear people having like lithotomy if they have kidney stones that need to be removed. You can also, litho will come up quite often when you're dealing with rocks. Anybody ever get, this is weird, even if you don't get them, you might know about it. But sometimes people get these little like hard clumps of stuff stuck in their tonsils, especially if you've had strep a lot, then you have what they call cryptic tonsils, which means they're full of crypts, not that they're hard to understand, they're cryptic, but they're full of little holes, and you get little clumps of stuff, and those are called tonsilliths, tonsil stones. Even though they're not stones, you can squish them with your fingers. Next up, this is beneath your lithosphere, softer, weaker rock, high viscosity, but it moves. All right, let's do it, Lucas.
Asthenosphere?
Asthenosphere, that's a fun one. Asthenosphere. Okay, what is beneath that? And it's stronger and stiffer. Piper.
Mesosphere.
Your mesosphere. Here's another one. Meso. Anybody know what meso means? Do you know? Colin got it. Middle. Okay, means middle. That's right. So if you look kind of at your Earth here, your mesosphere kind of is the middle of everything. Okay, so that's your mesosphere, middle. All right, and then the last part in the very center is going to be the Asher?
Core.
Your core. All right, very good. And your core has an inner and an outer core. All right, so here is a quick little video. Yes, it's a Lego man. These are cute. I tried to tuck in some of these short ones. We'll probably skip through some of it because it's a 6-minute video and you don't need a 6-minute video.
Do you recognize this?
No.
We call the Earth our home, but did you ever think about what our planet is actually made of? The planet is approximately 4,000 miles from the center to its surface. But what makes up those miles of Earth? The Earth is divided into different layers, just like this cake. Each layer has its own properties and is composed of different materials. Many scientists believe that as the Earth cooled, the heavier materials sank to the center and the lighter materials rose to the top. To better understand this, let's start our journey inside the Earth. Okay. First, let's start with the part of the Earth that we live on, the outermost layer called the crust. The crust must be solid, or we'd sink into the Earth's inside. It is made up of rock and loose material. This layer is very thin in comparison to the other layers. The crust is about 5 miles deep beneath the ocean and about 25 miles thick below the continents. The temperatures of the crust vary from air temperature on the top to about 1,600 degrees Fahrenheit in the deepest parts of the crust.
Let's start digging.
This place.
This is ridiculous, I love it.
Mantle is 1,800 miles thick. But before we talk about the mantle, we're going to look at two special parts of this layer that, together with the crust, have unique mechanical properties. The topmost layer is the lithosphere, which is a rigid layer made up of the crust and the upper layer of the mantle. It's typically about 60 miles thick. We can imagine the crust as the shell of the Earth. Actually, we can compare the Earth with a hard-boiled egg, and the lithosphere with its shell. The shell thickness divided by the radius of the egg gives a percentage of 2%. On the other side, the thickness of the lithosphere divided by the Earth radius works out to about 2% too. So the shell is to the egg what the lithosphere is to the Earth. The lithosphere essentially floats atop a semi-liquid layer known as the asthenosphere, which is about 60 miles thick. The material of which the asthenosphere is composed can be described as plastic-like. This allows the solid lithosphere to move around on top of the much weaker asthenosphere. The asthenosphere is a solid, but it is very hot, with properties similar to silly putty. Now that you know about these particular layers, let's get back to the mantle, though the name's not as fun as the other ones. The mantle is made of superheated rock. The temperature of the mantle varies from 1,600 degrees Fahrenheit at the top to about 7,900 degrees Fahrenheit near the bottom. Due to these great temperature differences from the bottom to the top, heat currents are generated that carry heat from the hot inner mantle to the cooler outer mantle, causing movements inside the Earth. Okay, now we're ready to learn about another main layer, the outer core. The outer core is a 1,400 mile thick liquid layer. It's mostly made of iron, so it's really heavy. The temperatures here range from 7,900 degrees Fahrenheit in the outer regions to 11,000 degrees Fahrenheit near the inner core. Without the outer core, life on Earth would be very different. The movement of liquid metals in the outer core creates the Earth's magnetic field, which allows us to use a compass. And here we are in the center of the Earth, the inner core. The inner core is a solid layer with a thickness of 780 miles. It's made of solid iron and nickel.
Oh my gosh, it is really hot down here.
The inner core may have a temperature of up to 13,000 degrees Fahrenheit, which is hotter than the surface of the sun. Many scientists believe it is kept in the solid state because of the extreme pressure from the other layers.
Wait a minute. I'm pretty sure nobody else has come down here. So how do you know so much about the Earth's layers?
Oh, the answer is actually quite simple. It's true we cannot study the Earth using our eyes, but we can use other senses. The most important thing we use to sense the Earth's inside are seismic waves. They're waves of energy caused either by earthquakes or by massive man-made explosions. Timing and strength of seismic waves gives us a picture of the interior of the Earth. Seismic waves gradually bend and change speed as the density of rock changes. Another way to see the inside of the Earth is based on the analysis of rock material brought to the surface from greater depths by volcanic activity. These samples can give hints about the properties of the interior region.
Awesome. There's so much going on beneath your feet and you don't even realize it. I mean, first we started with the crust, then the mantle, then the outer core and the inner core. Each of these layers is so different. They have different behaviors, different compositions.
We gotta take her seriously while she's got honey all over her hair.
It really is getting hot down here, so I think I'm gonna go back to the surface.
That was so cheesy.
All right, so minerals and rocks. All right, so you have what are naturally occurring inorganic, solid with a crystal structure, characteristic chemical composition. Drew, what are those? Minerals. Okay, what does inorganic mean? Somebody, anybody? Anybody who hasn't answered yet? Anybody? James, what's inorganic? Right, it doesn't, yeah, it doesn't come from a living thing. It's not a carbon-based thing, typically thinking, not produced by a living organism. So organic would be the opposite, which means it is produced from a living organism. All right, and then what's your solid combination of minerals? Milo, that's a rock. And we got all kinds of different kinds of rocks. Last year we did a lot of rocks because it was earth science, lots of rocks. All right, so we have different properties for minerals, things like their crystal structure, their color, their streak. That means if you scrape it along a ceramic plate, does it leave a little trail? Its luster, whether or not it's shiny, dull, density, how much stuff is there in the given volume of the mineral you have, how hard it is, can you scratch it, what scratches it? Some things you can scratch with your finger, others are really, really hard. You're gonna need like a diamond or something, or a really, really sharp, hard piece of metal to leave any scratch. How does it break? Fracture and cleavage. This is like if you break the mineral, does it break and make a nice, straight, perfect, smooth line, or does it snap into a bunch of pieces? And then other things like, are they magnetic? Are they fluorescent? Like under UV light, do they glow? Do they have electric properties? Jordan, what were you gonna say?
I know that when we hit a rock, it sort of, like the shockwave goes like in 45-degree angles. So
And
you can chop off like sides of rocks by
Right.
hitting it from a 45-degree angle.
right, like kind of like arrowheads were made from rocks and things like that. If you, there are certain rocks you can use that'll be really good for that, like obsidian in particular, which is igneous and it's really glossy. It's like glass, basically. It's glass. And they chip those off because they break easily. Their cleavage is a smooth line, doesn't leave a rough, like sandpaper type surface. It's nice and smooth. So how do we classify them? Okay, so igneous rocks, you guys should know this because you're all old enough to know this, but these are the ones that come from magma. So you've got igneous, sedimentary, and metamorphic. Y'all know this. So igneous rocks form from molten material that cools and solidifies either inside the earth or on its surface. So they form from magma. So what is a mixture of molten rock and gas that forms underground? Colin. Magma. All right, so this forms underground. All right, and then what do you call magma when it flows out onto the surface? Somebody who hasn't gone, who hasn't gone? You haven't gone, Xander.
Lava?
That's lava when it comes out. Okay, and we have two types of igneous rocks, some that form underground, some that form above ground. Chloe, what are the ones that form underground? Those are intrusive, and the ones that form outside on the surface, Liam?
Extrusive.
Extrusive. Very good. Now everybody's answered at least one. Oh, no. Hiding in the back. All right, sedimentary rocks. Okay, sedimentary rocks, these are the guys that are formed when you have fragments that are breaking down. So rocks are classified in three major groups, right? We had our sedimentary, metamorphic, igneous. Sedimentary sediment is small pieces of material that came from rocks or living things that is basically eroded and then it's weathered, eroded, and then been deposited somewhere. So sedimentary rock forms over time as sediment is squeezed and cemented together. So geologists classify sedimentary rocks into three main groups, according to how they form. There are clastic, chemical, and organic. So what form from fragments of broken rocks? Chloe.
Plastic.
These are our clastic. Very good. What form when minerals precipitate from a solution? Emily.
Chemical.
Okay, chemical. Now that means you have, like, say you have salt water, okay? And the water just evaporates. You're left with the precipitate, or evaporite in this case, and that is going to be your salt. You can also have chemical solutions that will cause solids to form within them, and then eventually those will squash together and you'll get another kind of chemical rock. And then lastly, what form from organic processes such as breakdown of living things? All right, Asher.
Okay.
These are organic ones. Can somebody think of a good example of an organic rock? Milo? Oh, that's a perfect example. All right, so then we have our metamorphic rocks. So these form when you've got heat, pressure, or chemical reactions. So here are 3 types of rocks, rock cycle. Y'all should know this. So this is a quick little video just to refresh in case it's been a while. I like the little puzzle, it's cute. All right, here we go.
Rocks are everywhere.
Yeah.
They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are 3 main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rocks make up obsidian and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found, since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure.
Standing at the shadows.
Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth, where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle. The rock cycle begins with magma, or hot melted rock, deep beneath the Earth's surface. This magma becomes crystallized, becoming igneous rock. These rocks begin to erode or break down into small pieces because of wind, water, or other forces. The small fragments of rock are carried away as sediment when water passes over them, and are deposited in layers, which eventually become sedimentary rocks. Then, some sedimentary rocks are pushed below the surface due to tectonic activity, where they are exposed to heat and pressure, transforming them into metamorphic rocks. If the rocks are buried even deeper, they may melt and form magma, starting the cycle all over again.
All right, so here's where you get your Menti thing out. Where is it? Here we go. All right, let's give it a shot and see if this actually works. Fingers crossed, it might not. So what type of rock is this? We're looking for metamorphic, igneous, or sedimentary. So scan your QR. This is a scan the QR code right there. And you should see the question in front of you. Did the question come up?
This is what it says. It says quartzite.
Oh, okay.
not obsidian.
Well, that's the wrong one then. Let's go to the next one. Where's the quartzite? Quartzite's what came up?
Yeah.
Okay, well, let's play this game then, because I don't know. All right, so quartzite. All right, hold on. There we go. Okay, here come your answers. Look at that. See it? You can see it live. So this one is metamorphic. For some reason that was not covered. Should be.
Looking at what this says.
There we go. So quartzite is metamorphic. So at least some of you were able to vote. Let's see if it'll let us do the next one. All right, let's try this one and see if you get a different quiz or do you get the same quiz. This is my first time using it. So this is kind of an experiment in itself. Same question again. If you scroll, is there another question or can you skip to another question? Should be able to. Shoot.
It's just the one question.
Wait, maybe I need to hit this button. All right.
There's a code underneath.
Oh my
You
God.
can enter somewhere.
Yeah, there is a code. You got a different one? What's the different one? Okay, I think it's, oh, here we go. Okay, y'all are all voting currently on this type. So this is granite. Is it igneous, sedimentary, or metamorphic?
I'm not good at that. I think it's igneous.
Not pulling up? Do we know?
It's way to get mine an hour of load.
Yeah,
Wait, what was it?
igneous.
Oh, let's go.
All right, so how about, let me see, should be able to start conglomerate. Okay. Do you see the question for, it should say conglomerate. What type of rock? Here we go. All right. Sedimentary, igneous, or metamorphic. Very good. Look at this. We are answering. I like it. Okay, it is working. Couple little tweaks, but I'm figuring it out. All right, so it is a sedimentary rock. Very, very good. All right, now there's the quartzite one. It should have, maybe it's gonna let you do the.
Yeah, refresh now to make the question.
Okay, there it goes. There's quartzite. And quartzite is metamorphic. All right, so that was cool. So keep that handy. There might be others, but I don't remember if it did. But anyway, that's good. It's good to know it works at least to a degree. All right, cool. So your rock cycle, we just went over this in a little video. You guys know it. Got a little magma comes up, turns into igneous rock, either extrusive or intrusive igneous rock. Y'all good back there? Then you get weathering, erosion, transportation, deposition, this whole deal. Y'all have seen this before, right? Y'all don't get to high school level science without seeing that. So plate tectonics. So this is the theory. Remember theory and law from your videos. This is the theory that pieces or a plate of the lithosphere move about slowly on the asthenosphere. Theory of plate tectonics explains the formation and movement of Earth's plates. Plate motions are visible part of the process of mantle convection. So the process of continents moving slowly across the surface of the Earth is continental drift. So who hypothesized that the continents were once joined in a single supercontinent, all of which broke into pieces, moved apart? Okay, my earth science people should know for sure. All right, Colin, do you know?
Alfred Wegener.
Alfred Wegener. Wegener, he's a good dude. So we like Wegener, Alfred Wegener. And who remembers what was the big deal with Alfred Wegener coming forth? He said, oh, I got this hot idea. And what did people say about it, Bailey?
They said it wasn't true because he had enough. It was a brand new idea, and no one liked it.
Yeah, that was part of it. That was a big part of it. It was an idea that nobody had ever heard of. What else, Drew?
He couldn't explain how.
He couldn't explain the how. That was a big deal. He could say, well, I have data to show it happened, but he couldn't explain the how. So what did we call this big supercontinent right here? All right, Yusuf? Pangea. This is Pangea. So plate tectonics are the cause of seafloor spreading. So at the mid-ocean ridge, which runs right down the center of the Atlantic, right? It's the largest mountain range. It's underwater. And the plates are moving away from each other. What kind of a boundary is it when plates move away from one another, Milo? That's a divergent boundary. Very good. So ocean crust is being formed on the seafloor and it's spreading as new crust is created at the mid-ocean ridges. The older crust is going to move away. So it's kind of doing like this constantly, right? So it creates new organic crust at mid-ocean ridges. Now, who knows what it was about the mid-ocean ridges and Alfred Venegar that finally got people to accept his theory? Who remembers? James?
The, uh, magnetic rocks itself,
Right,
pushing back.
right. Does anybody remember what that's called? Do you remember?
Yeah.
Seafloor yeah, magnetic seafloor striping. So some rocks have magnetic minerals in them, such as iron, for example. And right now we have, north and south poles, but they switch. They have switched throughout history. And you can see the minerals on the ocean floor in the rocks. You can see them switch direction in patterns that go like this out from the seafloor. So while the seafloor is spreading, they may orient this way, and then the poles switch, and now they're orienting this way. So when magnetic seafloor spreading was detected, actually during the war, when people were trying to look for submarines and such, they were able to say, oh, they are moving. Alfred was right like 40 years ago. Geez, right? So then we have different plate boundaries. We just talked about divergent. That's what Milo brought up. It was at the mid-ocean ridge. Now, what do we call them when they move towards each other? Towards each other. Oh, Caitlin. Convergent, right? And a subduction zone of ocean plates is seafloor spreads, heavier, more dense crust sinks below the neighboring plate. So that happens like right here in this middle image. So seafloor crust is very, very dense. And as it spreads away from like the mid-ocean ridge to the continents, and it runs into that continental plate, it's so much more dense that it's going to sink below or subduct under the continental plate, and then it will cycle back through the whole convection again. Convection is the idea that you've got heat that moves in cycles. Who remembers the lab we did for convection last year that was real? It was very hands-on. Piper? Tomato soup and crackers. We took some crackers, laid them on the top of tomato soup, turned the heat on, and watched them move away from each other, which is exactly what continental plates are doing. So the last one, boundaries where the plates slide past each other, Yusuf. Those are transform boundaries. Okay, and this is, where is our closest transform boundary? Anybody know? James? Yeah. We got ourselves a serious little earthquake zone over there, don't we? All right, so orogeny is the process of mountain building. Don't worry about that. Whoops. And geologists have found that most mountains form, let's just say form, whoops, I caught it, along plate boundaries. Okay, so we did a lab last year with mountain building where we actually put layers of pixie stick sugar in a little tank that had these paddles you could push and mush them together, and you could see all the layers as they form, just like mountains will form.
That was delicious.
It was delicious. Y'all got to take little scoops of it out with you.
Or it took a couple years.
Yeah, there you go.
It took a couple years.
So here's continental drift. This is a very short one.
Talk about the ultimate break-in. Europe and Africa have been splitting apart from the American continents for millions of years. At a rate of approximately 2.5 centimeters per year, the continents are moving about as fast as our fingernails grow. And as they continue to split, the rift between them, otherwise known as the Atlantic Ocean, will get even wider. And all this drama is leaving behind a major scar, an underwater valley called the Mid-Atlantic Ridge, which tears more and more as the continents slowly move apart. Looking back on the continental relationship, this is a mere 300 million years ago, when Africa, Europe, the Americas, and all the other continents were one big landmass. The famed supercontinent, Pangea. Due to the constant churning of magma underneath the Earth's crust, they all split up and moved to their modern-day positions. But if destiny in the form of magma and tectonic plates has anything to say about it, the continents might have a chance of getting back together. But how will these stubborn continents get to make up? Scientists believe the plates will shift, causing the continents to rearrange and get back together. But in true tectonic plate style, it'll take about 250 million years. Our planet has a violent soul. Majestic, often destructive, volcanic explosions rattle our collective events.
Terrifying.
Violence.
Violent planet.
And I hope that they'll get back together again.
Yep.
Planet is wild.
Yeah, I know, right? She was very dramatic and happy, and then it starts talking about, gloom and doom. So earthquakes, when you have movement in the lithosphere that occurs when rocks shift around and they release the energy they've stored, and we're gonna be talking about stored energy a lot this year. But these have energy that they've stored and that gets released, you get an earthquake. And that's the forces that are, the forces are released and it causes the shaking and surface shaking, but also waves, seismic waves that go downward into the mantle and in all directions. So what do we call the vibrations that carry earthquake energy? Let's see. All right, Lucas.
Aftershocks?
These are seismic waves. The aftershocks are the ones that come later. You can feel them. They're like little shakes that come after the big earthquake. Anybody ever felt an earthquake? I felt like kind of a one once, and I wasn't even 100% sure that I actually did. But like I've got a friend who just moved from Anaheim to Florida, and she is happy to be away from that business. She was not a fan. But yeah, we don't get them very much here because we're not at a plate boundary, a major plate boundary, but we still can have shifts in the lithosphere and we can still get them. They're just usually very small here. So as rocks break and move, potential energy is converted into seismic waves. There's a word, potential energy. That's a type of stored energy, and we're gonna be talking a lot about that stuff this year. So as your tectonic plates move, they cause stress in the crust. It turns, which in turn produces faults and folds. So what is a break in a massive rock along which movement occurs? That is going to be, Liam.
Fault.
That's your fault. Okay, what's our big fault in this country?
San Andreas.
San Andreas. That's where we're talking about in California. We've got a big plate boundary right there. All right, and what is a bend in a layer of rock? Yusuf?
Fold.
That's a fold. Okay, you'll see that sometimes. You'll see rocks that have like these weird kind of folds in them. And we could definitely see that when we did our mountain building with the 2 paddles and the pixie sticks. You could really see all the folds in there. So we have different types of seismic waves. So most earthquakes are concentrated along plate boundaries where faults are found. We have waves that are longitudinal and they compress and expand like an accordion. Then we have transverse and they move at right angles, like how a snake moves. And then we have others that roll, like dropping a pebble in a pond. So the longitudinal waves, the best way to think about it is, you know, an accordion goes like this, or you can also take, I think we did last year, we took a slinky, and you can take a slinky and your friend can hold the other end. And if you just pop it like that, you can watch the wave move through it. So that's a longitudinal wave. What kind of waves? What do you call those? There's a letter for it. Oh boy, Piper. Those are going to be our P waves, and then the transverse waves. So these are the kind that go like this, like a snake moves. Now they don't just go like this. They also go like this. They also go like this. Any of those planes, you have to think about that. James?
S wave.
Those are S waves. You can think of that moves like a snake, right? S, snake, that's an easy way to remember them. And then what do we call these rolling ones that are like a pebble in a pond? They go out, 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 out. Emily?
Surface waves?
Those are our surface waves. Yeah. So that is at the very top of the lithosphere. And it's just like that. Waves that go out like this. So to measure earthquakes and pinpoint their epicenters, epicenter is where the actual slipping occurred. Okay. Geologists record seismic waves using seismograph. Okay, there's another good word. Graph. What does graph mean? That's a good root or a base.
Right?
To write, correct. So if you see something graph, it means it writes. So a seismograph writes the seismic waves. That's put this in the picture right there. That's a seismograph. So what's the device here that records the seismic waves? Bailey?
Seismograph.
There it is, seismograph. All right. And then what is a scale that measures the frequency and amplitude of the waves? We have different scales that measure different things. Caitlin? Richter, yep. So this, you'll hear this most of the time. If you're watching the news, they very often will give the results of an earthquake. They'll give the stats as Richter scale. So that is going to be the frequency and the amplitude. What does frequency mean when we're talking about waves? Who remembers? Liam?
Like, how many times they go like up?
Right. How many times a certain part of a wave passes through a certain point? So if you're measuring by this point and you're measuring the crest of the wave, how many times does that wave crest as it comes along? How many times does it pass that point in a certain time period? So it's like The number of times per second, per minute, all right? And then what's amplitude? Who remembers what amplitude is? Bailey?
Or like the height of the wave.
Yeah.
the depth of the wave,
Mhm,
very
mhm.
gymnastics.
So you can measure from the midpoint to the crest or the midpoint to the trough, but what you're looking for is basically how tall is your wave, okay? So that's a Newton's cradle that I guess Eunice has found. Move the little balls and it sends the energy through. Those are fun. So what's the scale that discusses the amount of energy that's released? What's that scale? Describing what? We're describing what scale? Piper.
Moment magnitude?
Moment magnitude. Yep. Scientists use moment magnitude a lot. You don't hear it as much on the news, but it is a thing. And the last one is the one that goes by damage. All right, Emily.
Modified Mercalli.
Modified Mercalli. And this one, you would think the media would use this more often, but they don't. But this would be the most applicable to your life, right? How much damage did it cause? All right, so volcanoes. All right, so volcanoes, formation of volcanoes. You have a mountain that forms when magma reaches the surface, which is called a, let's see, anybody at the back table know this one? Really, do you know this one? A mountain that forms when magma reaches the surface. That's an easy one. That volcano, bing, coin. There we go. All right, that's a volcano. So what occurs when gases bubble out through the crack in the crust, propels the magma to the surface, Colin?
Eruption.
That's an eruption, kaboom. All right, we have different kinds of eruptions, right? We have some that just kind of ooze. We have some that explode really forcefully. So we have a chamber or a pocket of collected magma. That's a what? Caitlin? Oh, we're just looking for magma chamber. That's an easy one. There you go, magma chamber. All right, and then you've got a vertical chamber through which the magma reaches the surface. That's the what? The what, James? You're waving your hand. The pipe. That's an easy name. It's a pipe. It's easier than you think. All right, and then the opening at the surface is called the Yusuf. The vent. That's the vent. And then the bowl-shaped pit around the vent. Xander.
Crater.
Yeah, that's a crater. And then what's the collapsed depression at the top that's squashed in? Bailey. Caldera. There you go. All right. And we have different types of volcanoes, different shapes of volcanoes. So volcanoes erupt explosively or quietly depending upon the magma. So quiet eruptions. Somebody tell me something about quiet eruptions. Emily.
Shield volcano.
There you go. They form these shield volcanoes, and they're also very hot, low silica magma. Okay, silica is the stuff that makes up quartz. It's basically the stuff that makes up glass. It's also, when you study rocks, you can tell by the minerals in them, minerals cool at different rates. Okay, so as minerals cool at different rates, the silica ones, minerals that contain a lot of silica versus minerals that contain low silica. So silica makes a very thick, viscous material. So if it's low in silica, it is kind of oozes, right? But if it's high in silica, you get these explosive ones. And that's because you can think of it like this. If you've got, say you've got like a squeezy bottle and then on top you put like, I don't know, water, and then you squeeze, it just kind of goes, right? But if you put maybe honey or something thick on top and you squeeze, you're gonna have to squeeze harder, right? For it to come out because that surface tension is greater. And when it finally breaks, it breaks, right? So that's what happens with the thick magma. The thick magma, the gas builds up underneath and it causes it to just kind of fly out like in this picture. So location and type. Most volcanoes occur along plate boundaries or hot spots in the crust. Hot spots are where you've got thin crust and you've got magma kind of leaking up, or you've got magma really close to the crust. So what's the region where rock extends from within the mantle toward the surface? Go ahead, Xander.
Hot spot.
That's the hot spot. We were just talking about it. All right, good. So here are different types. All right, so Emily mentioned shield a minute ago. We've also got composite and cinder cone. So these volcanoes are the quiet eruptions, the low viscosity magma, they're wide and flat. And this is what Emily was just telling us. These are the shield volcanoes, and that's correct. Because they ooze out nice and slow, and they just sort of build this big, wide, flat mountain over time. So what are the ones that erupt ash and cinders, and they have really steep sides, Milo? These are the cinder cones. So these have very steep sides because they're throwing ash and stuff out. And as it comes down, it just collects on the side. And then you get this really steep one. And then the last ones are, all right, Liam, composite. And these are kind of a mixture, right? That's what a composite is. It's a mixture. It's like, eh. And then, all right, so other igneous features. Some of these are fun. So what do you call intrusive magma squeezed into a crack between layers of a rock? So squeezed in a crack. Piper. Okay, that's a batholith. Do we have a batholith nearby? Where's our nearest batholith? Bailey?
Stone Mountain.
Stone Mountain is a batholith. It was a big glob of granite that formed in a space underneath the ground, and over time it was forced upward, and then it's been weathered and eroded so that it looks the way it looks today. But it was a big blob underneath. All right, so the next one, when you have magma filling cracks that run parallel to existing rock layers. So like this, Caitlin?
So
That's a sill, and it looks just like a windowsill. Think about it. You've got layers that go this way and magma filled in one. You get a sill. All right. What is it when you have it filling this perpendicular crack? So it's going this direction, Colin?
Dike.
That's a dike. And the dike is another word for a dam, right? So if you think about a dam, it runs horizontal to the water and the land. Same thing. All right. And then when you have magma hardening up in the pipe, you get, Yusuf?
volcanic neck.
Yeah, or a volcanic neck. So all these things can be underground and they're really cool. All kinds of different stuff. Sometimes you can see the where you've had intrusive magma like quartz and whatnot, veins. You ever seen the veins within rocks? Same idea. So you get other features. So, ooh, this is the same. There's pictures that go with them. Had it on too. So that you can see the images of them. You've got your dikes that go straight up and down at horizontal to the layers. You got your sills that run with the layers. You've also got stalks. This is a batholith, this giant glob. Here's another dike going this way, another dike. And this is a laccolith, which is just another type of underground formation. All right, water. Earth's surface is 71% water. Most of Earth's fresh water is in the form of groundwater from underground cracks and in between particles of rock, fresh water. All right. So we've got atmospheric water and surface water. There's water in the air. We're in the South. There's a lot of water in the air, right? All right. So if you look here, here's Earth's water. So fresh water is the smallest point, and we have glaciers, ice caps, and groundwater. This should say glaciers up in here. I don't know why it didn't. It should say in the form of glaciers and groundwater. I will fix that. Ice caps. That's how I am today, man. Ice caps. All right. Glaciers and ice caps hold most of it. And then you're going to have that break down into this little bit of surface water. That's where you're going to have your lakes and permafrost, things of that sort, swamps, rivers. So it's actually a very small amount that's fresh water. This is important because this is what we drink. Okay, so 2.5% of all the water on Earth is fresh water, and almost 70% of it is frozen. So then we're left with 30% that's in the ground or on the surface. And that leaves us with only 20% of that we can access without drilling into the ground, right? All right, so atmosphere, there's a tiny portion of water in the atmosphere. You can see it in the clouds. You can feel it in the South. Anybody ever wear your sunglasses on your head when you're in a Target or something, and you come out and you put them down on your face? When you walk outside, they just fog up instantly, like you get the condensation on your sunglasses or your glasses. It's like, what am I doing? We had this problem during COVID when everybody had to wear masks all the time. Remember, people's glasses were fogging up because when you exhale, there's water in that exhaled breath, and it just kept collected on people's glasses. So you have streams and rivers. That's less fresh water than in the atmosphere. Then you have runoff that's flowing all over the surface everywhere. Tributaries are small streams that lead to big rivers. What is an area of land that contributes water to a river system? Chloe? That's a watershed. Okay, I still have yet to understand why this is something the government spends money on. But if you drive down the road, you will very frequently see little signs that'll say like Etowah River Watershed. Thanks for telling me. That's cool to know, but I don't know why that's applicable to driving down the highway. Anybody ever seen them? Look for him now. If you haven't seen him, you will see him. And it's odd. It's like, why are you telling me that? Like, I would get it if I was, I don't know, if they're trying to encourage you not to litter or not to let oil or gas spill out of your vehicle, but you would do that anyway, right? I would hope. Caitlin?
I've seen a sign for free dirt and it was like a permanent sign.
Nice. You're like, what? How much dirt do you have and why do you have so much? Okay, Liam?
Maybe they have the signs that like warn you in case of like floods or something.
Maybe. That's a good one. I really don't know, but I've always found that to be odd. I'm like, okay, we paid for that sign. I don't know why we did. And then you've got ponds and lakes, and those usually form in depressions or low-lying areas. And then your glaciers are these giant chunks of ice, right? That are nice and slow moving. And your icebergs are the kind that have broken off and they're floating along, bobbing along. And like they say, an iceberg, very little on the surface, most of it's underneath, right? They use that as an analogy all the time. So groundwater, most of Earth's liquid fresh water is groundwater. And that's down in cracks. And we have different zones, okay, as we drill down into Earth. We've got a saturated zone.
On the brownie point on the water table description.
Oh, did you? At top of saturated zone is the bingo, brownie point. All right, let me write that down. There's one. Don't even forget it. Very good. Well, what is the answer there? It's the water table at the top of the saturated zone. Is it? Okay, that's because I cut and paste right out of there. So there we go. So your saturated zone is your underground region where you got porous rock, it's filled with water. Your water table is at the top. So if you're drilling a well, you're trying to hit the water table, which is at the very top. That's what you're looking for. As soon as you get water coming up, you know you've hit that water table. And then what do you call, so permeable is when water can pass through something. What do you call a permeable rock layer that's full of water? All right, Piper?
Aquifer.
That's an aquifer. Very good. Aquifer is your underground water. It's like a little underground. It's either in the porous rock. Sometimes the rock is the pores are very small and you don't really see them. And sometimes they're bigger holes, right? So impermeable means water cannot pass through. Oh, I put permeable twice, huh? And then permeable means it can pass through. Some rocks are permeable, some are impermeable. So you've got a water cycle. Y'all know this. You've known this since like first grade. All right, so you got water moving around. Liquid water turns to gas. What's that part of the process called? When liquid turns to gas. All right, go for it. Ridley. All right, there we go. So evaporation is when you got water going to gas, but precipitation is when you have gas turning, well, it can be when it's turning, it's when you've got water in the atmosphere falling down. What are our types of precipitation? Let's go off her answer. Liam? Rain's one. What's another? Snow. What's another? Jordan?
Morning dew.
That though, sort of. That's close. It kind of, almost. All right. What's another one? Milo. Hail. Yeah. And Colin. Snow, sleet, freezing rain. We got it. All right. So who else is over there? Okay. So yes. What is it when water is released from leaves on trees? What's that one called? Emily?
Condensation.
No condensation. Close though. It's a shun. Colin. It's actually transpiration. So when part of the process of photosynthesis involves producing some water as a byproduct, and that water comes out of the leaves of trees, and that is called transpiration. And so that will occur as part of the water cycle, but it's the part people don't talk about very much. So when you have water vapor turning into liquid water, okay, Lucas.
Precipitation.
Close. Condensation. You have to have condensation in order to have precipitation. So you have to have one to have the other. And then what is it when you have liquid or solid water falling from clouds? Now we got it. Okay, Asher.
Precipitation.
Precipitation when it's falling from clouds. Yeah, there we go. All right, so water turns from liquid to gas. That's evaporation. When it goes from water vapor to liquid water, that's condensation, and then that will fall. That is precipitation. So watching our time, we got to kind of roll here. So weathering is the process by which rocks are chemically or physically broken down, and I'll give you those. The two types are mechanical or chemical. rain that falls on rocks and causes them to slowly dissolve. That would be a chemical, whereas mechanical is like if the water runs over the rock and takes away pieces of it, little tiny pieces of it at a time. And the rate of weathering, both mechanical and chemical, depends on three main factors: your temperature, how much water you have, and the type of rock you have. So if you've ever been walking like on a mountain trail, you might see some granite rock, and then there's like this white part that's like standing up above the rest of it. It's not as well eroded, it kind of sticks out. That's usually because that's high in silica, it's usually quartz, and that will weather at a much slower rate than the rock that it's within. So you can actually see that. Chemical weathering is fastest in warmer conditions. Does anybody know why chemical weathering is fastest warmest? Bailey?
Because chemical reactions go faster when they're warm.
Right, because heat's gonna lower the activation energy required for a chemical reaction, and then you're going to have more and faster chemical reactions. Mechanical weathering is fastest in colder conditions. Who knows why? Somebody from last year. Yusuf, do you know? Remember? No. Bailey.
Freeze thaw.
Freeze thaw, right. So say you have a little crack in a rock, water fills it up, it freezes. What happens to water when it freezes? It expands, cracks the rock a little more, rains again, fills that, freezes, cracks it a little more. So that's why it's faster in colder weather. All right, so mass movement. This is when you have big chunks of earth and rock moving around. So erosion acts through weathering, which is the force of gravity, and through the movement of streams, water, groundwater, glaciers, and waves. What's the process that wears down and carries away? Ridley. There you go. Erosion. So you have weathering first. That's the breaking down. The carrying away and breaking down and carrying away is erosion. And then through this whole process, everything is going to move down slope. Whatever you're going to have gravity involved is going to be pulling things towards the center of the earth. And we'll actually be doing a lot this year that makes it really clear why that happens. So your mass movement is your downward movement. So you can have rapid downslope movement of large amounts of material. Anybody know what that one is? Lucas, do you know?
Landslide?
All right, there's your landslide. Anybody want to be stuck in a landslide? I do not. Then you have rapid mass movements of soil, sediment, and water. Oh, we did, Caitlin.
Mud flows.
Mud flows, all right. And then you have slow, gradual downslope movement of soil. Colin, that is creek. Very good. And then you have weak layers of rock or soil moving downslope as one big giant unit. Yusuf? Slumping. Yeah. All right. So there are great images of this. We went over it a lot last year. It's not so indicative of stuff we're going to be doing this year, but still important to just touch on it. So how water shapes the land, water runs along the land, and it's going to erode depending upon its speed. So what's the process in which sediment is laid down? Colin. There you go. Deposition is it's laying down. So it's going to weather, then it's going to erode, then it's going to be transported, and then it is going to be laid down, which is deposition. And what's the process of particles bouncing along the stream bed? Do you remember, James? Saltation. Okay, so saltatory movement is the idea of jumping. Kangaroos use saltatory movement. Rabbits use saltatory locomotion, okay? And when you've got water in a stream, you get particles like little bits of sand or whatever, they bounce along inside of the stream. What is the other condition in which you have saltation involved with erosion and deposition? Does anybody remember the other condition, Bailey? Wind. Why are wind and water both having saltation? What's similar about them, Bailey? They're both fluids. Yeah, they're both fluids. Both wind and water, both air and water are fluids. And because they're fluids, you can have saltation, bounce, 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 bounce. Now think about that with like a sandstorm. Ugh. All right, so then you've got all different kinds of valleys, V-shaped valleys, waterfalls, meanders, oxbow lakes, floodplains. Since I drove across the country last week to Texas, we crossed the Mississippi, and I was watching on my on Google Maps, had the satellite view on. You can really see where the floodplain is for the Mississippi, also where it used to be, because it hasn't always been where it is, like meanders or little curves like this, and based on forces within the fluid, sometimes those get cut off and they make a lake that's shaped like a crescent, and that's an oxbow lake. And if you're interested, you can pull out your phone at some point and look at your Google Earth along the Mississippi, and you'll find them. They're everywhere. It's really kind of cool. They're very obvious. It's also why that's such fertile land, because that river has carried all kinds of minerals with it for thousands and thousands of years. So then you've got features made by water deposition. So not the flowing, but the dropping of stuff. So at the bottom, sometimes you'll have something called an alluvial fan, where you see like the end of a river. Delta is the same kind of idea. A delta is like a big mass sediment. Our big delta in this country is the Mississippi River Delta, where it empties into the Gulf of Mexico, and you can look at it on a map. It's shaped like a triangle. Delta is the Greek letter looks like a triangle, and that's going to come up this year too, because it also is the symbol used to represent what in equations? Do we know, Liam?
Change.
Change is the delta. Yep. So you're going to see that a lot, actually. It's going to come up. Groundwater erosion. So we get caves and all kinds of underground things that form. So what are the icicle-like formations, Milo? Stalactites, because they hang tight to the ceiling. That's how you know it's a stalactite. What is a pillar of minerals, Emily? That, well, if it's a pillar, it's connected top and bottom. So that one is, oh, that was a stalagmite. I'm sorry, you're right. It's actually, you can have columns, which is more specific. And then you're right about stalagmite. Stalagmite would be like, I might sit on that and get hurt because it's the pointy thing on the ground. If it collects all the way up and touches, then you have a column, or you have a stalagmite and a stalactite that come together eventually. And then lastly, your collapsed underground limestone cave. Caitlin?
Sinkhole.
That's a sinkhole. Those aren't fun. Sometimes those just happen in the middle of a road. There've been some videos recently of people just driving along and then the road's gone and they're gone.
We have one in our backyard.
Oh, do you? A little one? Yeah.
Oh, no, it's big.
It's a big one?
Yeah.
Wow.
It's like 7 or 8 feet.
Wow. And in a yard where there's all that gardening. Good gracious.
And there's actually a playground above it.
Oh, wow. Okay. So glaciers and wind. Glaciers can move. You have continental glaciers, especially in the past, that move along and they take sediment with it. You got glaciers that have formed in valleys. You've got glaciers that leave deposits, and then plucking, I think, is the neatest thing. As they're rolling along, they pick up boulders, for example, and then they'll drag it along and it'll abrade the surface. And then somewhere along the way, they'll just drop it. Yes.
Yeah, I brought a brownie
Where?
in the Emerald Bank book. So
Where is it?
right here.
What's it say?
It says how glaciers form, moss, and
Okay, got 2 brownie points. Okay, I'll put another one down. 1 and 2. Okay. Then you've got glaciers and wind again. So features formed by glacial erosion. This is when you get things like U-shaped valleys, cirques, horns, all these things. No, they just know this is not, you're not going to be tested on this stuff. Just, it's important to know. My favorite of these is actually an esker, which wasn't really listed in your book, but the esker is where, like, if you've got this giant continental glacier and it's moving along, you may have a portion underneath of it that's like, it's almost like an upside down stream. So it's flowing, but as it's flowing under the glacier, like the water cuts upward and makes like a little tunnel. And then the sediment still falls to the earth. So when it's gone, you have this like snake-like hill that just winds along. It's a big, long esker. They're really kind of cool. Till is the stuff that glaciers pull up as they go. And then you've got all, like I said, all kinds of different shapes of things. You've got that can be formed by glaciers. Just know they scrape along land and they do things as they scrape, leave different formations. Wind can deflate things. That's basically when it's blown away all of the sediment and poof, it's way down here. That would be deflation for sure. And then you can get dunes, and then less is when you've got like just globs of dust that have collected somewhere from the wind. So what proportion of salts are dissolved in ocean water? Do we know? Bailey?
You want the word or the percent?
Yeah, well, it was salinity. Sorry, I should have been specific. Yeah, salinity is the proportion of salt dissolved in water. And that, yeah, that changes with depth. So light and temperature decrease with depth, whereas pressure is going to increase. That makes sense. The further you get under the water, the more pressure there is, the less light there is, the colder it is. And then, you know, we talked a little bit about continental shelves. You don't need to know much about any of this, but it's important to understand that there are currents within the ocean, some on the surface, some underneath. Some are caused by higher salinity, higher levels of salt that make the water more dense. Some are caused by upwelling, which is when you've got movement of water from underneath the cold water and it's for some reason moving upward. Typically, you're gonna have your colder water sinking, your warmer water rising, which is exactly what happens in the mantle, because again, it's a fluid. Same thing that happens in a room. You know, like one smart thing they did when they designed this house is they did not put any air conditioning vents in the upstairs hallway. What really would be the purpose? It's a hallway, but you can walk up the stairs and feel the temperature increase as you go up because the cold air is going to sink and it pushes the hot air out of its way. Remember, hot air doesn't just move up. That's not what happens. Colder, denser air is moving down, pushing it up. Okay, what else do we have to cover? Just quick stuff. So you've got all kinds of ocean action, right? Causes different drift, causes different formations on the beach. Not something to be tested on, just be aware of it. Okay, now this, you've got rocks. How do we determine the age of rocks? So what happens when you compare the age of rock to the ages of the rocks around it? What do we call that, Caitlin?
Absolute age data?
Think about it for a minute. Not absolute. What's
Relative age.
the relative age dating, right? You're looking at the rocks around it. You're going, okay, these rocks are 450 million years old. So these ones next to it are probably close. And then your absolute age dating, we'll get to in a minute, but that's when you're dealing with carbon dating and stuff. Index fossils are also used. Okay, so that's certain fossils were formed during certain time periods on Earth. So if you find them in rock, you know roughly how old the rock is. And then superposition. This is oldest rocks are at the bottom, newest rocks are on the top. That makes sense, right? Worms and layers? That's superposition. Radiometric dating is the absolute. Okay, that's what we're talking about. Again, this is not going to be like major quiz stuff, but be aware of it. This is all, this first, we'll come back to this one. This first lesson is mostly just review and context. So the second lesson, and then we kind of get more into the meat of things. I'm actually going to leave this one in your email because we don't really have time for it. I'm watching the clock go by. So real quick, we're just going to breeze through these. Now, this might be on your homework, organizing. Okay. You got longest periods of time or eons, then eras. Then so eons are made up of eras, and you can see how they form from the bottom up here. These are the shortest periods, longer, longer, longer. So what are these ones that would go second from the bottom? Tens of millions of years. Chloe.
Tomorrow I need to leave.
Oh, you got it. Okay, go ahead. So these are going to be periods, and then the last one are going to be epochs. Okay. Let me give you your coins on their way out. All right. So just know that there are delineations of time and that they differ by how long they are. And then there are delineations of time that differ based on what period here. And I'm going to give this one to you guys as well. You good? You want your smile?
We really have.
Oh, yeah. All right, cool. So I'm going to leave this one in your email for you to watch. Again, short on time today because we had a lot to cover. This one I will leave for you guys. I'll leave it up as we leave for you to vote on. But this is going to be one more of these guys. And it's which book did I most likely read first? I'll leave it back up in a second. Extinct organisms are obviously dead. Okay, tonight what you're going to do, or this week what you're going to do. You are going to read. It's in your syllabus what you need to read. And and you're going to fill out your binder work. And you're going to bring your binder work back to me. Your homework in your binder back to me. You're going to keep your binder work in your binder, but bring your homework back to me. All right. And then this lab you're going to keep in your binder. Next week, it's up for one per team. All right. So what do you think of it? I'll leave that up if you want to vote. And I will put these out here. So y'all can grab your coins. Thank you for being so patient as we deal with technical stuff. It will get better. Promises, promises. Look for an email for me. Let me start this thing if you want to do it. There you go.
I can't have Skittles. We have places.
Oh, I'm sorry. That's what's in there now. It might change later. I have to watch because like M&Ms are in a factory with nuts. So people can't do that usually. So. A lot of the time, if they're very sensitive, no, because they're made in a factory that has nuts on the equipment line. Yeah. So it just depends on the person. Great first day, people. Awesome, awesome, awesome.
So the unit one
Mhm.
quiz stuff,
Yeah, I'll look and make sure.
Should I try and upload that to the student draft?
If you can, no, upload it to the assignment, that it's in an assignment in Teacher Ease. If you can upload it to there, awesome. If not, you can email it to me. But I'm gonna make sure everybody has it like by the end of the week or whatever, next week. We're gonna sort it out. It's all a mess. Yeah. Thank you guys. Have a great one. Awesome, awesome. Okay. Drew, vote for me. Which book did I most likely read first?
There's a like perfect coming bird.
Oh, is he outside?
No, he's dead.
Oh.
He's just on your driveway.
Oh, shoot, let me come get him then. Sorry, I didn't think of the point, but I grabbed 30 minutes, hummingbirds. Do you want to grab or do you want me to grab? It is dead. It looks gone. Everybody watch a bit. It's like.
You're gonna be like, one pencil.
I am one. Of the word that. My mom is the leader around here and it's not even start. Yeah. Yeah, I think. Yeah, by the. Lower and there's more, right? And they're thinking It's awful, I've been, it's 20 minutes, when they find together, the whole crew, like, take it out. And I find it out, but, you know, two or three people, yeah. Oh, they do. Three. Got to spell out, and they let her write this resume. Yeah. But I'm believing. Sit that. Hot buttons, both of you. It's been in the sun and not that would be quick, you know, I'm not. Totally competitive. But I have our. He should follow the tail on our red dot football and then, you know, yeah, it's nice. I spent months last year trying to get a letter of invasion of this plant. Parking lot, outside to navigate, center. It's a different name, and it's something that's expected out of this month, right? And you have a first position and everything. I thought, please, I can be here again, and like the last presentation, everybody's. And I'm off there, body, just, getting to the road, you know, I got mold, another really work. Some of them I re-articulated wire and whatever, but I can never, a rat, just this game with my stuff. And I probably went on when people play, like, they get nasty, yeah, they very aggressive when you just get that into each other. Like one will sit there and watch Peter, yeah, what? And almost there and watch Peter, and then dare to go for it, and then another one will flying out of the woods, but she's been watching the whole time. There's a ton of here. There's that you need to, you know, get resource. Yeah, yeah. And just have it around there. And stuff around the oh, I believe it, yeah. So later, okay, you guys, have a good one. You'll get 2 emails from me in a little while. Sorry. Yeah, no, it's not you. It's teacher's nightmare. I know it is not. They don't get copies. It's children. That's what you get. Yeah. That's what you get. Shame on being put. Excellent. All right. Glenn, we'll see you this week. Sorry, dear. Perfect. There 1:30, but we ran a couple minutes over and then people were cranking the machine on the way out the door. We'll be getting faster as we go. James found a hummingbird in the driveway. He said it looked like it just fell out of the sky. He's right, it did. Dead, but absolutely perfect, not a mark on it. Very weird. Good boy, Oswald. Hello, sweet boy. Hi. Hey, baby. Didn't know you disappeared.
They were cranking.
Yeah. Yeah, the pupper wepper grabbed a few errant Skittles and was very happy about that.
Why?
Well, they hit the ground, so we grabbed them.
He was that, but you were.
No, he was very happy about the rent.
I got a custom call too.
Yeah. Alexa, turn the living room off. Alexa, turn the pub off. Alexa, turn off hallway light. Alexa, turn the kitchen off. Alexa, turn the kitchen off.